In this video on circles and parametrics, we've got three little problems to solve. First one can be done with GCSE maths really. The second one a little bit more complicated using some of the lesser known trig ratios. And the third one is about parametrics. So let's start with this first one. We've got the area P, which is a minor segment of a circle, and the area Q is the major segment. And very conveniently, because this chord here divides the circumference in the ratio 1:3, we know that we're actually dealing with a quarter of a circle. All right, so that makes the whole problem quite easy. So we go from there to the center, and from the center up to there, that's a right angle because it's 1/4 of a circle. We know that we have a radius r, so we have enough information now to work out quite easily what P is. So the area P is a quarter of a circle, so it's a quarter of pi r squared. Okay, and that needs to have subtracted from it the area of the triangle. If I just use half base times height, that's a half of r times r, which is a half of r squared. A common factor in both those terms is a quarter r squared. Okay, so if I take that out, okay, I can just write pi minus 2, because a half is 2/4. So that's the area of P. Now, to do the area of Q, the easiest way is just to recognize that it's what I've just worked out, okay, subtracted from the whole circle. So Q is going to be pi r squared minus P. Okay, and it's pi r squared minus a quarter of pi r squared. I'm going to write it like this because I can refactorize it. And then I'm going to take away minus a half r squared. So it's plus a half r squared. Okay, so be careful with that. Now, if I take out the same common factor that I took out here, that would give me a quarter r squared. Okay, and then I'm left with 4 pi minus 3 pi, minus pi, which is 3 pi. Okay, that's just combining those first two terms, plus 2. So the ratio I need, which is P to Q, I can just simply take those two parts I've just written and put them side by side in the same order. So it's going to be that to that, but because I've got a common factor of a quarter r squared, that just cancels out, so I'm just left with pi minus 2 on the left. Okay, and to the right of that I have 3 pi plus 2. Okay, and that's using exact answers. Okay, so that's how I would answer the first of those problems. Okay, in this second problem here, we have some triangles sort of arranged around this circle. And before I start to find the side lengths in terms of x, I'm going to just put some information on here which will help us. And that is that there's a right angle here where a tangent meets a radius. That makes lots of triangles that are similar to each other. If this is x, this is also x up here. And we can also see that this would be x in here as well. Okay, so that's going to help us with these various right angle triangles that we've created. Now we'll start with CD. Now CD is simply going to be from that smallest triangle here, okay, opposite over hypotenuse is CD over 1, which is the sine of x. So CD over 1 is the sine of x. Okay, quite simple. And the next one, OD, in the same triangle, is the adjacent over 1, is the cosine of x. So OD equals cos x. So that's the first two done. Now we come to do OA. Now OA, if we look at this angle x, OA is the hypotenuse and 1 is the opposite. So 1 divided by OA is the sine of x. So therefore OA is 1 over the sine of x. Okay, so OA is 1 over sine x. Okay, and if you've done A-level maths, you will know that that can also be written as the cosecant of x, or just cosec x. Okay, so that's there. Now, the next one is AC. Okay, now AC is the line that goes from here to here. Now that's adjacent to x with 1 opposite. So opposite over adjacent is 1 over AC, which is the tan of x. Okay, so AC must therefore be 1 over the tan of x. Okay, and again, if you've done A-level maths, you will know that 1 over tan is cotangent or cot x. Okay, and now we've got CB. Now CB, if we look at this larger triangle here, not the very large one, but this one here, using this x, CB is opposite, the adjacent is 1, CB over 1 is the tangent of x. So CB is simply tan x. Okay, now we come to work out the last one, OB. Now OB is this long line across here. Now that is opposite this x. Okay, so this x here, opposite that is OB, and the adjacent of that is OA, which we've already worked out. So opposite over adjacent is the tan of x. So what I need to do is say that OB, okay, is going to be it's going to be OB over 1 over sine x is tan x. Okay, so OB is therefore going to be 1 over sine x times tan x. Okay, now tan x is the same as sine x over cos x. So the sine x's will cancel, and that will leave you 1 over cos x. Okay. And 1 over cos x is the same as sec x. Okay, short for secant. And that's the answer to the last one. So that's a bit more tricky, but they are the answers that they would be looking for in terms of trig ratios of x. Now the third question is really A-level, but some of this would make sense to GCSE Students who know about certain things such as the sine squared plus cos squared equals 1. So let me explain how this works. The curve C has parametric equations given as shown there. Now, the first thing we do is we can express t in terms of sine t and cos t in terms of x. So I'm just going to do that here. So if this first statement is true, then subtract 3 and divide by 4. So x minus 3 and divide by 4 is going to be the same as sine t. Okay, and similarly we can do for the other side for y. Y plus 1 over 4 is going to be equal to cos t. Okay, now to make a Cartesian equation we have to eliminate the t completely, so it just contains x and y, and this is actually the equation of a circle or part of a circle. And what I'm going to do is square and add to both sides and set them equal to 1. You see, that's how it works. So for part A, well, it starts up here really. Okay, so sine squared t plus cos squared t equals 1. Okay, I'll just write that here, and then we can go on and use our expressions in terms of x and y for t. So what I'm going to do first is multiply everything by 4. So when I square, I'm going to end up with a denominator of 16. So I'm going to set the right hand side to 16. So I'm going to have that x minus 3 squared, okay, x minus 3 squared plus y plus 1 squared, okay, and each of those would have had a denominator, you see, of 16, 4 squared. So I'm going to put that over here, in other words multiplying the 1 by 16. So that's the equation of a circle. Okay, so I've written that in the form x minus a plus y minus b squared equals c. Sketch C, labeling the endpoints of the curve with exact coordinates. Now, to do this, I need to look at what happens with these parameters. The range given is minus pi by 2, which is like minus 90 degrees, up to 45 degrees, or pi by 4. Okay, so what I do is I take the two limits. So I'm going to say when t equals the lower limit minus pi by 2, okay, I can see that x minus 3 over 4 is minus 1. Okay, x minus 3 over 4 would be minus 1. Okay, because the sine of negative pi by 2 or minus 90 degrees is minus 1. Okay, that gives me that x is minus 1. Okay, and when t is minus pi by 2, it tells me something about y as well, and that is that y plus 1 over 4, okay, and that's equal to the cosine of negative pi by 2, which is 0, and from that I can see that y plus 1 must equal 0, so y is minus 1 as well. So that gives me the coordinates of one point in the circle. Okay, and then I set t equal to pi by 4. and that tells me that x minus 3 over 4 is equal to the sine of pi by 4, and the sine of pi by 4 is 1 over root 2, or root 2 over 2. And if I rearrange that, I can get that x would equal 2 root 2 plus 3. Okay, and also when t is pi by 4, y plus 1 over 4 is equal to root 2 over 2 as well, because both the sine and cosine of pi by 4 are the same. Rearranging that, I get y is equal to 2 root 2 minus 1. Okay, so they're the x and y coordinates of one point, they're the x and y coordinates of the other points. And just to give me a rough idea what that is, okay, this is just to help me with the sketch. Okay, 2 root 2 is about 2.8 plus 3, which is about 5.8. Okay, and 2 root 2 minus 1 is going to be 2.8 minus 1, about 1.8. So this is only just to help me with my sketch, just to get a rough idea of where these points belong. Minus 1 is quite easy. Well, rather than try and do a sketch on this tablet, I've already done it here, just so you can see what it looks like. Okay, which is quite clear to see. So when t was minus pi by 2, the point minus 1 is there where it begins, and it ends when t is pi by 4, which is this here. Okay, and next I'm to calculate the length of this line. Now what I'm going to do this is recognize that it's part of a circle. Okay, and in fact you can see that it's exactly 3/8 of a circle. If I just draw this in here in a different color, let me show you what I mean. So I can go to the center of the circle, which must be here at the point 3, minus 1, and you can tell that of course from the Cartesian form here. Okay, and it goes up to there like that. So that is 3/8 of a circle. So the length of an arc of a circle is r theta, where theta is the angle in radians. Okay, so if I just put that as theta, and that angle there is so it's 3/4 of pi, isn't it? So the so arc length, so arc, okay, that's the length of the red line, is 3 pi by 4. Okay, because pi is 180 degrees, so it's 3/4 of 180 degrees times the radius, and the radius of the circle is 4. Okay, well, the 4's cancel, so it's simply 3 pi. Okay, and that is the answer to the question. And that's the answer to the first part. Well, the first part is the sketch, so that's all there. Okay, hope that was helpful. Take care.